Okay, we can also do inference for a difference of means. And when we're doing this, that means we have one categorical variable, which is going to give us the groups, and one quantitative variable, which we're going to use to compute the means. And just like inference for a single mean, when we do a difference of means, we're approximating using the t-distribution. And we need a formula for our standard error. And the way to get the standard error is the square root of the standard deviation of group 1 squared over n1 plus the standard deviation of group 2 squared over n2. And the conditions to use that approximation are that both groups need to be normally distributed, or both n1 needs to be greater than 30 and n2 needs to be greater than 30. And again, we could use R as a big calculator, or we could use functions. And I'm going to focus on the functions part of it. So I want to know whether the mean number of years of school completed is different between people who were born in the US and people who were born outside the US. So we can start by computing our point estimate, our best guess, and that's going to be a difference of means. So I'm going to do mean, and then I'm going to have a y tilde x. The y is my response variable, and in this case, it's going to be the numeric variable, tilde whatever I'm going to break things down by, which in this case is the categorical variable of born in the US. And let's just hit the play button. And let's see, so the mean number of years of school for someone who was not born in the US, 12.8. The mean number of school years for someone born in the US, 13.969. And I could do the difference of those means. So let's see, 12 thing and this 13 thing and subtract them. Now let's hit the play button. Okay, negative 1.12. So it looks like people who were born in the US have a little bit more schooling, but we want to know, are we pretty confident that that's the case, or could it actually be sort of going either way? And then are the conditions for inference met? So we need the data to be normally distributed, or we need both those groups to be greater than 30. I think the easiest way is going to be to see if those groups are greater than 30. So I'm going to just throw another R chunk in here, and I'm going to do a tally and tally up the born in US and then data is equal to GSS, because this is going to tell me how many people are in each group. Looks like 169 people in the no category and 1,223 in the yes category. And so, yes, both groups are greater than 30. And now we could make a confidence interval for that difference in means. So I'd like you to see if you can figure out what will go inside that t.test function. And you could pause the video for a second while you think about it. And now I'm going to do it. So I think the easiest thing to do is just copy what was inside your parentheses for the mean and put that into the t.test. And if you hit play, let's see, I think this is working. We've got the mean in group no, the mean in group yes. Those look like the numbers that I got in my original mean. And then I've got my 95% confidence interval. And then we could interpret that interval. So in this case, we are 95% confident that the true difference in mean number of years of schooling between people not born in the US and those born in the US is between negative 1.8, maybe all around, and negative 0.45. So this interval, all being negative, means that we're pretty confident that people who were in the group no, people who weren't born in the US, they actually do have fewer years of schooling. That kind of makes sense to me. If you're an immigrant, there might have been other things going on in your life, and you might have had a little bit less schooling as a result. And then the last thing that I want to talk about today is inference for paired data. So there's different ways to do it in R. The easiest one is just to make a new variable that's differences and do inference on that one single variable. And if you remember about paired data, it's easiest if the data is naturally paired. My data set doesn't have like a perfect natural pairing, but they do have data about the highest year of school someone's father completed and the highest year of school someone's mother completed. Of course, people might have two fathers, two mothers. They might, be raised by a single parent. But a lot of these people have data for both of those variables. And so I could make a new variable called diff, and we could do inference on that. So if I hit play on this code chunk and then click on my data set and scroll all the way over to the side, now I've got this diff variable. So the first person has a difference of -8. The second one has a difference of -4. And we could see why that is. Okay, the father, 0 years of schooling. Mother, 8 years of schooling. 0 minus 8 is -8. And now that we have that just one variable, we could do inference just like we would for a single mean, like last week. So we could find our point estimate, and we could do a t-test just like we did in that single sample lab. And you could think about how to transform this to work on our differences data. So just think about that for a second. So the thing we're going to change is this variable. I'm going to change it from number of hours worked last week to diff. And then I could hit play, and it gives me this 95% confidence interval. It goes negative to positive, so we wouldn't be very confident that there was truly a significant difference between those two things. So that's how we would do inference on paired data. It requires the data to be transformed a little bit, like making a new variable.